I think once you understand fractions, you understand the concept of comparing, combining. If you understand this next concept, the rest of these whole video will just be using these same things over and over, these principles. And this concept is called equivalent fractions. What in the world does equivalent mean? You ever heard that before?
Yeah.
Where did you hear that word before? In math, that's right. It's because you've learned a little bit of fractions. But equivalent means equal, equivalent. It means they're equal fractions. And the way I define equivalent fractions is 4 words, makes it a little bit more practical. Same amount, more pieces. Same amount, more pieces. Now, you may have never heard of this guy. His name is Jean-Jacques Piaget. Educators should understand it as Jean-Jacques Piaget. But he studied something called conservation of matter. And when I was taking education classes, I was a little skeptical until I tried it on some students, and it really works. Little kids think that more pieces means more amount. You know that young preschoolers would rather have 5 pennies than 1 nickel, right? Mm-hmm. Then when they start saying, no, I want silver, they're understanding that that 1 nickel is the same amount as 5 pennies. Ready? Just more pieces. And then when you get older, you want paper, right? Because you can keep your coins. I just want the paper. I want dollar bills. All right, so this is the concept. And before you add, subtract, or divide, or multiply fractions, you have to understand this. And so you might have to spend some time here. But the good thing is, if you make math something that kids can see, then it's not abstract anymore. In fact, the word is concrete. It's really plastic. But it's concrete, and then you understand it. And I've taught first and second graders stuff that they shouldn't have been able to learn with their developmental because we made it so they could see it, all right? So here's how we're going to illustrate it first. And let me just run through it, and then I'll tell you a story using it. If you want to build it with me, take your 1 and put this fraction on top of it to make 1/2. Now I generally steer clear of 1/2 because oftentimes 1/2 is just like a 1 step. People say half. And I want people to understand that there's 3 aspects to fractions, right? See how I made the 3 this time? See? 3. So there's first what you start with is 1. Then we divide it into 2 equal parts. Then we take one of those parts. Now, take your other overlay that looks the same as this one. I'm going to need to borrow yours for just a second. Now, what fraction is this, everybody?
1/2.
1/2. What fraction is this?
2/4.
Whoa, let's count them all first. 1, 2, 3, 4 is the denominator. How many are colored? 2. So, and that's the same amount, right? I didn't change the orange piece, did I? No. Still the same amount we started with. Now it's this. Now take this one off and put your third overlay on top of it.
And it's 3, 6.
It's 1, 2, 3, 4, 5, 6. Or we could skip count. 3, 6, 3. Still the same amount. And now take your 4 overlay and put that on top.
4, 8.
And we could do 4, 8, or 2, 4, 6, 8. And we have 4 that are colored. And take your 5 overlay and put that one on top.
5 times 10.
You already know the answer, huh? Okay, so it's 5/10, or there are 5 colored and 10 total pieces. Everybody see that?
Yes.
Now let's see if we can make a word problem out of this. Let's pretend that I'm hungry and that I go to this local pizza parlor and I say, I'd like to get some pizza. How much do you think I should get? And the owner looks at me and he says, I get 1/2 of a large pizza. This is it. What do you think the toppings are on it? Anchovies. Ugh. Pepperoni, cheese, tomato sauce, sausage, onions, mushrooms. No. Okay, whatever you want.
Pineapple.
This is pizza, not pineapple or anchovies. Ugh. Okay, so I say to the owner, I said, I'll take 1/2 a pizza with the toppings. And then he says, well, how many pieces do you want me to cut that up into? 2 or 4 pieces. And what do I say? You better make it 4, I'm starving. Why are you laughing?
Because it's the same amount.
Because it's the same amount of pizza. Because you're older than 8 years old. But if you're about 8 years old and under, they're thinking, yeah, good move, good move. If you want more pizza, you get more pieces. And it really is something, because remember that for birthday parties, just keep cutting it up and they'll think they're really pigging out. But anyway, here you go. Here's my half a pizza. And I put this one on top, and I have 2 pieces. Is it the same amount of pizza? But it's more pieces and smaller pieces, right? Okay, what if I put the 4 overlay on top? Same amount of pizza? But more pieces yet, and they're smaller pieces, right? And so we know that 1/2 is the same as 2/4, same as 4/8. Now, personally, if you just teach this without the overlays and just show this, I think you stretch your credibility. What do you mean? Just go doubling things when you feel like it? See? But you have to show that the reason that we're using these numbers is because this is what the blocks are telling us, or the overlays, right? Okay. Try another one now. Build 3/4. 3/4. 3/4 of 1. I'm going to stop saying of 1 after a while because I get tired of saying it. But as long as we're using the overlays, you can assume that. And start putting the overlays on top. You need this one first. 3/4 is now what? 2, 4, 6. 2, 4, 6, 8. 6/8. And then put your 3rd overlay over and your 4 overlay, just like in the book, and you'll find more equivalent fractions. But the key concept is same amount, but what? More pieces. It's an equal fraction, it just got more pieces. So 3/4 is the same as 6/8, 9/12, 12/16, and 15/20. And you might notice something else too. You notice the multiples here? This is skip counting. 3, 6, 9, 12, 15, 4, 8, 12, 16, 20. Okay? Just to show that all the stuff that you've been learning all these years, it all is coming together now, especially when we do upper level stuff. Okay.